Welcome to Linax Actuator Academy video series for industrial actuators. I'm Hunter, and today we're going to talk about an I/O actuator's parallel features, one of several options configurable within the Actuator Connect configurator for Linax I/O interface. With an I/O actuator, it's possible to run multiple actuators in parallel without having to worry about complex cabling or control methods. The actuators communicate directly with each other via their own internal bus system. Regardless of any variations in the load, the actuators stay precisely aligned when moving, and the master will always ensure that the followers are present in the system and send feedback on the current position and status. All I/O actuators are prepared for parallel with the violet wire, meaning that you can set up your actuator for parallel movement even if it was originally programmed as a single actuator. The parallel option is displayed on the left sidebar in the Actuator Connect screen. When selected, you can configure and change the number of actuators in the parallel system. This setting determines the number of actuators that an IC parallel system must include in order to operate. You have the ability to link together up to 8 actuators, enabling smooth synchronized parallel movement. But you'll want to make sure that all actuators in the parallel system have the same configuration across all features. These two actuators here are both programmed with the same configuration, so they'll run in parallel together. So if we send a signal to the black or red wires, we can move in either direction. Or the other way. Let's talk about how the parallel system is designed. Parallel works as a critical system, meaning that all actuators must be present in the system before it allows movement. The system is controlled by a master, which is the actuator with the highest serial number. The master commands the followers to move and receive status messages to ensure that the system is allowed to run only if everything is functioning properly. If it detects a malfunction, or one of the followers struggles to keep up, the master will slow down so that the whole system follows the slowest in the system. This is common if the load is not evenly distributed in the application. The system can be powered by one main power supply, or it can be powered by individual supplies corresponding to the number of actuators in the system. When doing this, be sure to pay attention to the actuator specifications regarding voltage levels and current consumption. If separate power supplies are being used, they must have the same potential, and the power supply, ground, or blue wires, must be connected. If an overload occurs, the actuator will be stopped and blocked in that direction until an activation in the opposite direction has been made or the system has been repowered. Here's an example of a parallel system with 4 actuators operated from one main power supply. All violet wires are connected to each other, ensuring that they can communicate status messages and position feedback to the master. Run signals can be applied to the red or black wires and do not necessarily have to be connected to the master. As mentioned earlier, it's important that all the actuators in the parallel system have the same configuration. If there's a need to make minor adjustments or reconfigure the actuators in the system, each one must be connected to Actuator Connect one at a time. This process can be sped up by connecting via Bluetooth instead of a USB cable, thereby avoiding the time-consuming process of unplugging existing cables when the actuator is already mounted in the application. In this case, I've cheated a bit and renamed one of the actuators in Actuator Connect. This makes it easier to identify the actuator that I want to connect to. Here you can see that I have an actuator called front left in the list of devices, which reflects the location of my actuators in the application. The other one has a default name, which is the work order number of this specific actuator. In addition to parallel, you could easily imagine a scenario where you want to copy the configuration that you have made on the connected actuator and paste it to the rest of the parallel actuators. On an I/O actuator, you're allowed to do both configuration and monitoring. Via Actuator Connect, you can configure the I/O actuator values like ramping and communication settings, deciding on communication speed and other parameters to make the actuator fit your application. The parallel system is designed to constantly monitor the status of all actuators present in the system. If an actuator loses track of its position, the system will enter recovery mode. In this mode, actuator movement is still allowed in both directions, but with reduced speed, and the system will require initialization. Be aware that a parallel system in recovery mode only moves simultaneously, not in perfect parallel, so be sure to pay attention to rigid connections in your system to avoid binding. To reinitialize, you'll want to run the parallel system inwards until all actuators are below the 0 point of 35 to 70 millimeters. Then run again upwards past the 70 millimeter point. Recovery mode won't activate if the wrong number of actuators is connected in the system, such as when an actuator is being replaced. To replace an actuator, simply power down the system and disconnect the actuator, then place in the new actuator and reconnect all cables. If the actuators are not in parallel when starting up, the next movement after initialization will run in the following manner. This way you can easily replace an actuator even when the replacement is in a different stroke position. We hope you enjoyed this introduction to parallel features within Actuator Connect, and that you can use this knowledge to think outside the box when designing future applications. If you have any questions about Linac I/O actuators or the options that come with them, feel free to contact your local Linac office. Thanks for watching.